Hello, everyone, and welcome to this meeting to listen to a presentation about the Caverion use cases in this SMART-PDM project. The speakers in this PowerPoint presentation are me, Tatu Pekkarinen, and my colleague Miikka Tammi from Ramentor. As a result of the project, we see dependability analysis as a routine and visible procedure. Achieving this result requires automation at several different stages of the analysis process. Dependability analysis also leads to a systematic and optimized sensor placement. I would also like to highlight the important point that dependability analysis must be able to explain in plain language without difficult terms in order to achieve the set goals and not leave the project as a single exercise. This was the first thing we did when the project started. Finally, once this automated RAM analysis process is managed well, we will have the answer to the strategic question, which is also visible on this slide. How do we help our customers to achieve high reliability performance and creating a high reliability performance culture? The project deals with two use cases from different fields of industry. And when it comes to things like failure rate, repair time, production losses, just give two examples, these use cases have different characteristics. Hydropower plant is very critical infrastructure for electricity supply, so we don't want unexpected failures to occur. Maintenance operations need to be optimized by dependability risk management and condition-based maintenance operations. The entity under RAM analysis is also huge, and this is just one reason why we need automated execution instead of manual work. We have made great progress in this with our Finnish partners, and I'm very pleased about that. Second use case comes from the forest industry. This is a sawmill. In this type of environment, we typically have a lot of events and deviations in the production process. Deviations are often very short in duration. However, we must also be prepared for failures that individually cause, for example, significant production losses. So there is a need for both agile maintenance operations and smart predictive solutions for critical equipment. The requirements are entirely consistent with hydropower plant use case. For example, the coverage of dependability analysis should be comprehensive and up-to-date. Automated RAM analysis leads to optimal sensor placement. In this way, the potential of the sensors as well as other improvement actions is fully exploited. Here was my part so far, and now I have the pleasure of giving Miikka Tammi the floor, or in this case can be said channel. Please, Miikka.
Thank you, Tatu. Next two slides presents the current state of our automated RAM analysis process in a nutshell. Elmas software in the middle of the slide is a tool for modeling and analyzing the event logic. Elmas includes the most common risk analysis methods to support overall risk management. During this project, our research and development work has focused on following three areas. The first one is the development of efficient methods for automated model creation. The second one is development of efficient algorithms for simulation of large models with various data fields. The last part of our research and development work has focused on result views, dashboard planning, and development of interfaces to IoT platforms. Currently, automatic LMAS model creation is possible based on the device hierarchy, and the model can be expanded using event history. Generally, all kinds of categorized data can be used to expand LMAS model. That includes, for example, event history, including failures, maintenance actions, resource needs, and costs. The idea is to import all the interesting data and create a data model what can be analyzed by LMAS simulation. Currently, all the data is imported to LMAS from Excel file or files. In the use case of hydropower plants, the automatic LMAS model creation is based on a huge amount of devices and event history. About 15,000 devices and 10,000 events has been imported into LMAS model. Currently, the automatic LMAS model creation based on these devices takes about 15 minutes. Model expansion based on the event history takes about 10 minutes. Totally, there is over 20,000 nodes in the model, and the current simulation time is less than 10 minutes. At the sawmills use case, we have well over 30,000 events generated by the automatic data collection system and maintenance management system. The LMAS model itself is a bit smaller, but event history is larger compared to case hydropower plants. Simulation time here takes also about 10 minutes. Different kind of result views have been developed to support the analysis of LMAS simulation results. Our goal is to make the reliability and risk analysis process more efficient and results more visible. Our solution is to integrate the LMAS with WebEye's IoT ticket system. IoT ticket is a way to visualize the LMAS simulation results in the form of dashboards. It also enables connection to different kind of sensor data. This slide presents the architecture of the RAM simulation gateway tool that is developed during the project. WebEye is here the main architect, and the idea is presented in more detail during the WebEye presentation. Thank you. Tatu will continue here.
Here are the next steps of the project. So let's go through these. Of course, we will continue risk assessment modeling for both use cases. This means identification of critical objects from simulation results in terms of reliability and costs. Moving towards a smaller entity and predictive reliability analysis. After these, improvement actions such as sensor placement will also be planned and implemented in practice. During the project, we have so far succeeded in reducing the customer's production failure time by 13%, and the number of failures has been reduced by 11%. This can be considered as a significant achievement in the project. Continuous work is also done to detect various constraints and feasibility related to RAM analysis automation. However, the goal is clear and we are making good progress towards a higher degree of automation. Deployment work with SMART-PDM service application continues, and connecting real-life signals to the system will be considered later. It is also good to remember that feedback is important in this project as well. It will be collected and reviewed now, but also in the future. Thank you.